Hey class, Bob Greevy here. I want to talk to you a little bit about Chapter 3. Chapter 3 deals with sensitivity analysis. In Chapter 2 we introduced linear programming and we talked about some concepts in Chapter 2 like decision variables, objective functions, and constraints. This builds on that, so I want to hit those real quickly. In this example, what I'm going to do is we're going to solve using Excel, just like we've already done, a linear programming problem. And that's going to take just a couple of minutes, but what we're going to do then is perform some of the sensitivity analysis that is performed in your textbook. And what I want you to do ultimately, maybe the second time you watch this video or the first, is work through this with me. So if you're wanting to do it the first time you watch the video, you might pause here and type this problem you see in front of you. I'm going to talk about it real quick to review. In this example, we have an objective function that's a maximization function. So this could potentially be profit or revenue or something good because we want to maximize it. In this example, we have x1 and x2 as our decision variables. To give some context, maybe x1 is the number of product 1 we're going to produce. Maybe x2 is the number of product 2 we're going to produce. So these represent the number of something we're going to produce and sell. They could represent something else, but that's a simple thing to think about. So here we have three constraints then, in addition to our non-negativity constraints. The first one says that, hey, you can't produce more than 6 of product 1. Okay, x1 must be less than or equal to 6. We don't have the equal sign under here. I pulled this from a PowerPoint, and I guess they didn't put the less than or equal to. But understand that each of these constraints is less than or equal to. The second constraint, 2x1 plus 3x2, this must be some type of resource, and we have 19 units of this resource. So this 19 represents capacity, and this is a function that expresses the amount of that resource that we will use. So oftentimes, particularly with a maximization problem, you'll have right-hand side values on the constraints that represent a resource, a constrained resource, and then the left-hand side of those constraints represents the amount of that resource we'll use. So, for example, maybe this is machine hours or labor or material, and this is the amount of machine hours, labor, or material that will be used, and of course you can't use more than you have. Okay? So what I'm going to do now should be review from an earlier video, but I want to go ahead and walk you through it real quick. I'm going to go quickly because you've seen this. I'm just going to put some labels for my decision variables in cells A1 and A2, and then the actual decision variables will be represented by cells B1 and B2. I need an objective function cell. Let's call that profit. So let's say that 5x1 plus 7x2 is representing a profit function. And I'm going to translate that to read equals 5 times B1 plus 7 times B2. Again, now B1 and B2 correspond to x1 and x2 in the problem. Now we need those three constraints before we can jump into the solver. The first one, the left-hand side is simply x1, so I can type equals B1. The right-hand side is 6. The second constraint equals 2 times B1 plus 3 times B2 is the left-hand side. The right-hand side is 19. The third constraint will be equals B1 plus B2. The right-hand side is 8. Now all I have to do is go into the solver, which is under the data tab, click solver, and I've set everything up nicely. I can now set the target cell as B4 because that's where my objective function is. I am in fact going to maximize B4. By changing cells, my decision variables are B1 and B2, and then I've got to add those three constraints. Now I can say this cell must be less than or equal to this cell. Click add, do the same. A7 must be less than or equal to B7. Click add. And A8 must be less than or equal to B8. Click OK. So now I've set this problem up. That was a review. What we're going to do now shortly is solve the problem and then perform a sensitivity analysis. So let's talk for just a second about why you why you perform a sensitivity analysis. I'm going to go ahead and solve that. And I'm going to click sensitivity, and it's going to give me a report in Excel as well. Click OK. And now you'll notice I have the sensitivity report down here at the bottom. We'll check that out in just a sec. So why perform a sensitivity analysis? Well, the reason you're going to perform a sensitivity analysis is because a couple of reasons. Number one, this 5, for example, this 7, for example, may be assumptions. We may not have complete certainty that we can, for example, make $5 on every product one we sell. We may just be assuming that we can make $7 per unit on every product 2 we sell. So we want to see how robust our solution is. So the optimal solution says to produce 5 of product 1 and 3 of product 2 in our effort to maximize our profits. And if you do that, the most money you can possibly make is $46. Okay? So what we're kind of depending on is our ability to get $5 of profit for every unit of product 1 and $7 of profit for every unit of product 2. And sometimes, we all know, sometimes you have to put products on sale, for example. So the question is, can we really get 5? And if we couldn't get 5, would it change our course of action? And that's what we're going to test with sensitivity analysis. If that 5 had to change, would we do something other than produce 5 of product 1 and 3 of product 2? Okay? If that 7 were to change, would we do something different? And that's what part of the sensitivity analysis is about. Now, if this 5 could become a 4, a 3, a 2, and it's still the best thing to do, produce 5 and 3 respectively, then we have a robust solution. But if that 5 became a 4.9 and you suddenly produce something entirely different, then we have a solution that is very sensitive to that 5, to that particular coefficient in the objective function. So those are the types of questions we're going to answer. The other type of question we're going to answer is these right-hand sides of these constraints. One thing we want to know is, what if I was to add one more unit of that resource? So maybe this 19 here represents a particular material that I have to go out and purchase. So I only have so much material, and that's constraining me from making more money. And in fact, it is here. You've got a 19. Recall the left-hand side is the amount of that resource we're using. So with the optimal solution, we're using every bit of that second constrained resource. Okay. So what I might want to know is, what if that was a 20? What if I had one more unit? What if I had one more unit? How much would that raise profits? And that's something called a dual price, and we'll look at that. What we're going to do is we're going to look at the sensitivity analysis in the next second video. We're going to look at that sensitivity analysis. We're going to make sense of those numbers, okay? And then we're going to actually test it. We're going to rerun the problem and prove to ourselves that the results of Excel's sensitivity report are in fact correct. So, to recap, the purpose of a sensitivity analysis is to test your assumptions and also to see what would happen if we could get our hands on additional resources. So if, for example, that 19 becomes a 20, if I get one more unit of that resource, and that raises my profits by like $5, and that resource only costs $3, well, I'd want to continue to do that. So these are the types of things we're going to talk about in our next video. I've got to split this up because I'm limited in how big the video can be to get it on YouTube. So this is the end of this part 1, and jump back into part 2, and we'll continue from here.